All right. So this is AP Calculus Lecture 2.3c. This lecture is titled Higher Order Derivatives. So we're going to be taking the second derivative, the third derivative, etc. And I don't really have any notes to give you, just a couple of example problems. So our first example problem, we're on page 122. We're going to do number 76. And it says, find the second derivative of the function. All right, find the second derivative. Okay. Well, let's rewrite this to make it easier to find the first derivative. That's 1 plus 32x to the minus 2. Bring that x squared upstairs, make the exponent negative. Now we can get the first derivative, which we call f prime of x. The derivative of 1 is 0. And so this would be negative 64x to the minus 3. Now I'm not going to make the exponent positive yet. Let's wait until we take the second derivative. The second derivative would be double prime, f double prime of x. Okay, so that would be 3 times 64, negative 3 times negative 64. That's 192x to the minus 4. So now we'll clean it up in the end. That's 192 over x to the 4th power. Okay, let's do another example. Number 82. So it says find the higher order derivative. It says that the fourth derivative, so I guess after 3 we give up with the little tick marks, but the fourth derivative of x is 2x plus 1. We want to know what is the sixth derivative. Okay, well first we have to find the fifth derivative. So that's just going to be 2. And then the sixth derivative would be 0. So that's all there is to it. So for this homework, you're going to be taking some higher order derivatives, but you're also going to be doing some velocity acceleration type problems. So just want to remember from a few lectures ago that the velocity is the derivative of position. And therefore acceleration, or not therefore, just acceleration, is the derivative of velocity. So therefore, acceleration is the second derivative of position. Okay, so if we were to do this, with our nomenclature, if you start out with s of t, then v of t, the velocity, is equal to s prime of t. A of t is equal to v of t, v prime of t, excuse me. Get to take the derivative of velocity. And that's just going to be the second derivative of position. So if you want to get acceleration, you have position, you just need to take 2 derivatives of the position function. Okay, the homework starts on page 122. And we have 73, 74, 76, 79, 80, 81, and then 87, 88, and 90. So 73, 74, 76, 79, 80, and 81 are all higher order derivatives, like the two example problems. 87, 88, and 90. All right, so in 87, they give you a velocity function. They want you to find acceleration when t is 3. Also find the velocity. And then they're asking you a question that hopefully you remember from physics that you can answer. 88, they've given you the velocity function. They want you to find acceleration. So you can do that. And then 90, they've given you position. And they want you to find the velocity and acceleration functions, and then answer a couple of other questions there that are so more of a physics free fall type problem, except it's on the moon instead of on the Earth. All right, so that does it for this very short lecture. Hope you enjoyed how short it was, and I will talk to you on the homework problems.